Hello, everyone. So my name is Danubio. I'm from CloudWalk, and today I'm going to present the paper about emerging abilities. And the title is "Are Emerging Abilities of Large Language Models a Mirage?" And the motivation behind these choices is that currently we've seen a lot of hype regarding large language models displaying unseemly new abilities and emerging with new behaviors that cannot be predicted or that is sharp in a way that they suddenly appear and in a way that few iterations before or in smaller scale models, such abilities or such behaviors could not be displayed as well. And the key things here that the authors do to test this assumption that the emerging abilities is a mirage is that actually first the keynote here that he uses to define what is an emergent ability is the sharpness and the unpredictability of a new behavior. So as we're going to see later on some graphs showing how this displays on the metrics of performance, but basically as you go increasing the model scale, you start seeing new behaviors for specific metrics. And the key point here for the paper and for the author is that these metrics that have been chosen to measure the performance of the model are the reason, the root cause for us to see these emerging abilities. And the three tests that they perform here to understand and prove that this is not the case at all, that this is actually a mirage, is that they're making tests and confirming the predictions on the effect of metric choice. And for this, they use the InstructGPT and GPT-3 family, and they use this on specific tests that other researchers have been claiming emergent abilities for this. We will see later that there is actually quite recent publications for Google itself claiming emergent abilities and using as reference the same metrics that the author here tries to debunk. And the second point is to make, test, and confirm true predictions about metric choices in meta-analysis, because here on big benches, since some models like Palm are not available to openly, we can only test the analysis that have been made before, right? And the third point here is to show how similar metric decisions can suggest the apparent emerging abilities on vision tests. So the goal is to try to induce the emerging abilities on convolutional neural networks, where we often don't see anyone claiming that such models can display emerging abilities. And so during the introduction, the author mentions the more is different, which is a paper from the 70s. And although the paper has a topic based rather on physics, it aims to introduce and explain the emergent phenomena from the nature's point of view. So for instance, turbulent behaviors and other things that arises from the complexity, the complexity of different entities interacting in a very complex and unpredictable manner, and then arising with emergent behaviors. But the thing here, the important thing is this very interesting paper, this more is different point, and this is the starting point for us as a society start studying and understanding what is this emergent phenomenon like. economical phenomena that cannot be explained by splitting their parts, and others social phenomena as well, like and not just that, but emergent behaviors that we see in purely natural environments, like an ocean ecosystem that displays a particular behavior or property as you look at it in the context of all the entities that are related to each other, right? And such properties cannot be understood or reduced by looking at the individual parts. And so, and here the emerging ability of large language models, which is and colonies, right? Exactly. And here the emergent abilities of large language models, which is a paper that actually introduces this debate and introduces this idea of large language model displaying emergent abilities, have these results being displaying that at a given scale it has a sharp left turn, right? But as the author will show us later, it often only occurs when you have measurements, metrics for performance that are nonlinear, which means that they will either evaluate to true or false. It will be 1 or 0, and then for tasks that require a given number of sequential steps, it will clearly perform better at large scales, because you are only measuring the final prediction, if it is correct or not. So you're doing exact string match in this case here. And okay, so this actually here is from the whole paper. This is one of it is the most important part to understand what is the point of view of the researcher, right? And we're talking about this part here, but the point that the emergent behavior start appearing for specific tasks under specific metrics is that such metrics that are used to display such emergent properties are always nonlinear or discontinuously, meaning that they will be metrics that will be used in tasks that will do something like this, like a multiple choice grade. If the high probability mass is correct, then you will attribute the correct result for the model, and you will not take into consideration any processing that has been done previously. And the exact string match, if the output string exactly matches the target string, you will consider it correct prediction. And this here is more easily can be more easily visualized, because imagine you have a sequence of strings like a 7 token length, and then you will only evaluate to true if the final answer, if the final prediction is an exact match of the target string. And if it is like 7 tokens in length and the model predicted correctly 6 out of 7, you will still attribute to 0, right? And then when you look to this metric displaying a graph, you will see sharp turn lefts, showing that the model seamlessly emerged with some ability of predicting the whole string, which is an illusion based on the metric chosen for the evaluation, for this case in particular, right? And here's the author displaying what would happen if you change the metric used, right? So emergent ability here, accuracy. So here is a case of exact string match, where you see a sharp increase in performance as the model scales. And when you remove the non-linearity of the metric, and you instead start measuring the performance of the model based on the number of tokens, wrong tokens that the model is getting, you don't see such sharp behavior in such sharp turn lefts on the model ability of predicting exact strings, right? Because here you are just evaluating how the model is getting better in getting less token wrongs, right? While here you're just evaluating if it will get the final answer right or wrong. And okay, so here is the three things that the author will do to explain his assumptions, to prove his assumptions. And there is another point here that I would like to talk about that will take to another point there. No, it's not here. Oh yeah. Before moving on, because we talked about the original paper, it is interesting to note that although this author here is aiming to debunk the idea of emergent abilities, the original paper about emergent abilities, which is this emergent abilities of large language models, already states that using exact string matches to evaluate a metric for long sequence targets can disguise compound incremental improvements, which is the thing that we can see here in this other graph here, which is doing the same performance evaluation, but under other metric, and showing the compound incremental improvement of the model, right? So the original paper about emergent abilities appearing on large language model already states this. So it's not like this author here is saying something that's completely new that no one have ever considered before. But the problem is that people have been using these metrics here to kind of advertise emergent abilities, right? And you can see on the Palm 2 technical report from last week, actually Google states here that he actually uses the same experimental setup for this other paper here, which falls in the same metric mismetricing that the author from the paper I'm presenting is debunking, right? So there is a paper here which is using big bench test to prove that chain of thought behaviors, and the setup for this paper here is the same setup that Palm 2 researchers are using to make this statement here that the Palm 2 improves more than 100% and demonstrate new emergent abilities. So even though we know that such metrics cannot be used to correctly infer that the model can have or not an emergent ability, we have seen recent publications using the same metrics and the same setups to continue with the same statements about emerging abilities, right? And something interesting about this is that Google did not input it in the technical report concerns about emerging abilities. Instead, this is the single line where it talks about emerging abilities in a marketing way about his model having 100% improving performance, while in other side, GPT-4 technical report vastly talks about emergent behaviors in a risk manner in in an atmosphere that creates the sentiment that we should investigate why this happens and how this happens, instead of just advertising it as a feature. But yes, indeed. Okay, and here
Can I make questions now or just in the end?
No, yeah, any moment.
Yeah. So I don't know. Maybe I missed, but it's not clear to me why this explanation would debunk the emerging abilities, because what I understood is that, well, because of the metric, we hide the incremental improvements, and we see like, okay, at this size, the model doesn't have the ability, but at a bigger size, now it suddenly has. But in theory, no, but in reality, it's actually just, well, normal improvements. I just had a smaller ability before that I wasn't seeing because of the way that I was measuring it. But, well, for me, the ability is still emerging. I mean, it might be emerging incrementally, but it's still emerging. So it's not clear to me why the change on the metric would make the emerging ability a mirage. Got it?
Yeah. The idea is that the definition of emergent abilities that the author is using is that, well, this, just to make a point here, this is the emergence concept that the author from the original emergent abilities of large language models is using, right? Just to defining as when a quantitative change in a system result in a system can result in a qualitative change in behavior, right? And just to conclude here, just a moment. And then the author here, it starts by using as a reference the paper from that I mentioned before. Just a moment. The paper. Go ahead, Matheus, just to find here the section where he defines the emergence concept.
To answer the question for Alan, as Danubio will talk about in the paper in sessions 4 and 4 of the paper, they will go into the metrics that were evaluated on some of the large language models, and they see that, like, for most metrics, like this emergent ability doesn't happen. And then they also do a check in the lambda models. They just check that they change the metric to a similar metric, and they see that the behavior is like it's linear, right? It's not like it's like a sudden increase in the performance of the model. So they also test this from the metrics, the big bench metrics. And they also have a joke, kind of like a joke in the end of the paper, but they also check this part as well. So they check the metrics that are used, at least in one, to check in one family of metrics and language models.
Yeah, and it's also a matter of the concept of the emergence properties, right? Right in the beginning, during the introduction, the author referenced the paper for this physicist, the Anderson's, where he kind of defined there the emergence concept, and it basically it's something that you cannot predict through the evolution steps of something scaling, right? As something is scaled, it will suddenly appear with a given property or behavior that you could not have predicted by looking at past versions of the same scaled model, right? And And it is this the case. The debunk part here is that, as Matthew said, let me jump further. The author shows that when you change the metric, you don't have that concept of emergence anymore. You don't have something appearing out of nowhere. You don't have that sharp left turn. You have something that you could have predicted by looking at past smaller scale models, right? You can see that, oh, this is getting better at predicting individual tokens. And then you could infer that, oh, if we keep scaling the model, it will come to a moment where it will start predicting the whole sequences correctly.
But isn't that just an issue with the definition? I mean, okay, I can predict. Now I'm saying, okay, now I can. So, okay, it's not that. But, in the end, you still have a new ability emerging. It's like looking at an ant colony, like you have one ant by itself cannot, make the whole work and, well, all the different tasks that ants in groups can do. But when you get a bunch of ants together, they suddenly start doing things that, one ant couldn't do alone.
I think,
if you tell me just something, so if you tell me, okay, I can see that if I have like 100 ants, they kind of start doing these things. So I can infer that if I use 100,000 ants, they will be much better at this task. Well, okay, yeah, but it's still an ability that emerged because you put a bunch of ends together.
Yeah, but I think it's more like the definition, right? Because when I was reading the paper, I got a bit confused as well, because to me it was like also like that. But then when at least my understanding, other people can change, like from reading the paper, is more like how unpredictable, like out of nowhere, like it is really a lot, right? But yeah,
if you change the definition, it would suddenly be okay again.
At least that's like when I got your question was like when I started reading, people were like, yeah, I guess that's it. And then I was reading, people were like, oh no, at least from like what they explain on the image and stuff like that, to me, like the emergence that they say is like how like they have the model and they increase, and they out of nowhere like just jump like on a given metric, right? I don't know.
I think they're debunking the idea of a singularity. You suddenly have like a completely new unpredicted capability. So I think this is a pretty big deal. Like we're not going to see like with 1 billion parameters you can't do something, and then with 2 billion you're suddenly like at a new level of intelligence. I think the point is the progress is continuous. Of course, there are new abilities being acquired as you grow the model and the capacity. But the point is the performance grows continuously. There's a there's a continuous gradient of performance improvement. And this feeling that we get that suddenly the model got new abilities, like we've all been there. Like we noticed a big sharp turn in abilities from GPT 3.5 to 4, right? Like we all had this feeling. We all had this subjective assessment that suddenly the model got way better and able to perform new tasks. I think that the point of the paper is that this is more due to a phenomenon of how we measure these tasks, the performance in these tasks, and how we perceive the level of performance, than actually being something that suddenly appears at a certain scale of number of parameters or something.
Okay.
And the point is, when you define differently, these thresholds will become different also. So this is not something that is natural, intrinsic to the models.
It's just the words, or it's it's a bit misleading maybe, because in the end it's not saying that new abilities not emerging, but that they are emerging just in a different way than we thought.
Yeah, but that depends. What do you consider? For instance, imagine like nuclear fission, right? There will be, if you keep inputting the material, there will be a moment where you will reach the critical mass, and then there will be explosion. right? There's no half exposure or 0.7% explosion. Or it will explode or it will not explode in the moment where you reach the critical mass. So would you consider the explosion an emergence? Because you can track, you know exactly how much mass you can input until you are just about to reach the critical mass, right?
Well,
would
I
you
would-
consider the
I
explosion
would,
critical mass?
honestly, because I think it's different phenomena that we are talking. Like the way I see emergence is, well, complexity coming out of simplicity. You know, like you put a bunch of simple things together and you add them working together, and something more complex emerges. You know, like the ant colony again. So and the model is like that. You know, like, okay, I'm predicting the next word. Okay, so but now suddenly, not suddenly. Okay, suddenly it's that, maybe that's the problem. the word
Yes,
suddenly.
certainly. The problem is,
You know,
is exactly that. Suddenly.
you know, you put, okay, a few billion layers there, and it starts to, you know, show abilities of problem solving, for instance, you know, and it gets better at that, doing that simple stuff. Now this ability of doing a more complex thing, it's emerging. And you know, if you look at just the beginning, you know, the unit of calculations there, I would never guess, okay, so this thing you know, will, but this thing of never guessing or thinking that suddenly happens, I mean, that's not the most important things for me, honestly. It's more like, okay, a new thing that wasn't supposed initially to do that. If you look at the unity, when you put a bunch of things together, now it shows a different behavior. You know, it's like the unit of the parts do something different than just one part.
Yeah, but I believe that's exactly what the author is trying to state, that this is not happening in this large language model under the emergence abilities that have been claimed in the
So that's what I'm just not seeing. I mean, with this explanation, I mean, what we were talking now, like, okay, it's not suddenly, it's not unpredictable. Okay, I get it. Why the way that's being measured creates this illusion of being suddenly, or the illusion of being unpredictable. But in the end, it's still doing things that the smaller parts couldn't show. You know, if you have just one, well, let's say one or a model that just predicts one word, you know, it would never be able to problem solving. You know, because it can. I mean, just say one word.
Yeah. About this, actually, friends, just to show these findings here are from the big bench, right? And looking at just another context, this is like multi-step arithmetics, right? And then looking at the big bench part that performed this test, this benchmark on multi-step arithmetics, it is predicting the final result here. It is not taking into consideration if the model got part of the equation right and just missed one simple thing. No, it's considering that is the answer is 4, the string is an exact match 4 or not. If it is 4, then okay, it is correct. If it is not 4, then it's wrong, and everything that he did is not taken into account in the performance measurement. And the thing here is that the author is showing that if you look at the incremental improvements that will happen along as the model scales, you will see that it will start getting more and more parts of the equation right until it reaches the moment where it will be able to correctly find the final answer, right? And the emergence behavior that have been claimed that the author is trying, between quotes, to debunk, is this sharp increase here, like out of nowhere, like suddenly the model can do math, you know. But yeah, it's a paper that is generating a lot of discussion on the web, because a lot of people will agree or not. Me particularly, I'm very excited about AI having emerging abilities and so on. But that's why I stumbled on this paper to try to still mend the argument, because I was very eager to find material that would agree with my desire to have emerging abilities on AI models. But okay, so this is the.
I guess you can, I don't know, Danubio, I guess maybe you can continue your presentation.
Yes, and then the. Okay,
We're discussing the alternative explanations for emergent abilities, I suppose. Section 2.
Oh yeah. Okay, yeah. So the alternative explanation here is the one that we're just talking about, like the instead of looking at the metrics that non-linearly will scale as the model scales, right? We look at the metrics that will scale linearly. Like instead of taking a look at the full string, exact string match, let's look at the per token error rate that the model will display. And okay, so here he defines the mathematical strategy that he will use, and then he talked about the cross entropy loss as a way of not falling into the trap of getting these non-linearly scales on the performance metrics. But taking a look on the, there's not this part here. Just a moment. Yeah, it is. And yeah, so after testing that, the performance on models with multiple string lengths of tokens, you can take a look in the accuracy metric, which will make use of the exact string match to infer if the model is right or wrong. And here in the token edit distance, we will not be using a non-linear or non-continuously metric, right? So in this case here, you can clearly see that it is not displaying any sharp behavior, and it would be way more predictable to look at these results here than the other one, and one would hardly think of an unpredictable emergent ability by looking at the per token rate instead of the exact string match performance, right? And and this one here is exactly the one that I was showing here. This is the task that he is doing there, which is just multi-step arithmetics and evaluating the final part of the response. And here he specifically evaluates the Instruct GPT, GPT-3 emergent abilities, and here again, after going on with the tests, he finds that changing the metrics from non-linear and discontinuous to a linear and continuous metric will reveal that the model, instead of having sharp behavior, will have a smooth behavior. And also, other point that I didn't mention about here is the increasing the resolution of measured model performance. So not having enough test data to increase the resolution of during the performance evaluation is also a reason why we see these emerging ability claims happening today, because the author here will show that by increasing the resolution, you start removing the unpredictability of a model performance, and this is the estimation of accuracy when you increase more the test data. And there's actually a key point here. Just a moment. Yeah, here the part where the author is testing. If you keep the model output fixed and you test it for the metric that we talked about, which is nonlinear scaling as a function of the model scale, if you keep the output fixed and you just change the metric, you will see that the sharp behavior will disappear. And it's important to note here that there is no changes in the model outputs, right? It's under the same scenario, the same output, and the emergent will disappear as the resolution increases, right? So as you have more test data, as you increase your resolution, you will start seeing less and less sharp increases in your performance evaluation, even when you remains with the same accuracy metrics. You tend to see less emergent happening on the results, and here is the part where this is actually important, because here he used the big bench meta-analysis to infer that like more than 92% of the emergent abilities will appear under the same two metrics that we talked before, like the multiple choice grade, which is a nonlinear, which will scale nonlinearly, and the exact string match that we talked about and show already. Okay.
No, I think it's just good that you explain again the big bench, like it's a benchmark, right? That they do to evaluate the models, right?
Oh yeah. Big bench is this tool right here, where you have the best performing models here, and you can evaluate it evaluate the benchmark for these models in over 200 different tasks to see how they will perform under certain circumstances.
Yes, it's a bunch of different tests to evaluate the model, right?
Yes. And then there is the 39 metrics that Big Bench uses, and only on 5 metrics at most it will appear some emergent behavior showing up, and in 90% of the emergent abilities will appear on the 2 metrics, which is the multiple choice that we talked, and the exact string match. Again, showing that to see emergent abilities on large language models, you must be on a very specific setup, right? And okay, so yeah, here is just explaining the summary that I did here. And okay, so replacing this is actually the image that Matheus talked about earlier, displaying what will happen when you are replacing the nonlinear and discontinuous metrics to remove the emergent behaviors, right? And so you keep the same model family fixed, and you just change the big bench metrics, and then you go from this to this, which is clearly like if you take a look, for instance, in the logical args here, which is this green line, you will see that there it's clearly displaying a sharp left turn here, and you just change the metric and it disappeared, right? And this is one of the parts that I would like to discuss more with you guys, because I believe that this is something that have a very meaningful impact in our work here, which is inducing this emergent ability on other type of models, right? And here he states that we don't have claims that emergent abilities happen on vision tasks, for instance, because these metrics are usually not used for such tasks, right? And once you use those metrics that scale non-linearly on deep neural networks, you actually see the emergent behavior happening, right? So you have a field where people don't use these metrics for evaluating model performance, and therefore we don't have claims on this field about such models displaying emergent abilities. But then when you use these metrics, like artificially inducing these emergent behaviors, you will see the same improvements and same sharp behaviors displaying for the same text that previously was just smoothly increasing in performance as the model scales. So showing that aside from large language models, you can infer the same thing on other models as well. And yeah, here is the same idea being applied to a different metric. And another example. And okay, so all right. So other than that, I would like to show some discussions here. Yeah. I don't know, Matheus, do you want to make some point about the paper? You were
Well,
about this.
I mean, you still have stuff to talk, right? To finish the paper, right? You go to the discussion.
Yes.
But yeah, I think like just comments for now. I think like it's really interesting this section 5, right? They create some metrics. So like, instead of classifying one image per time, you are getting a batch of 5 images. You have to classify all of them to be 1. And if you get any wrong, is 0, right? And they add this, and then even like Examinist, they test on like very simple data sets. And it's like a simple network, right? No attention at all. And it's kind of, I think that's one of the interesting things. Like they create this thing, and then they say, oh yeah, we can do a graph that kind of looks like we got, right? They even go, right? I think figure 7 or 8 are the best ones, right? Because they put like an example of the GPT on the left, the green one, and then they put like their linear metric on the middle, and then on the right side they put the metric that they got with the reconstruction, right? So you can kind of see like it's kind of similar, right? Based maybe in a similar type of metric, like you can see that they can kind of induce the same behavior regardless of the architecture. It's not attention, it's not stuff like that. So of course, not really saying that attention is not good. I mean, attention is the best thing since sliced bread, right? But it's kind of funny how they're able to kind of reproduce the behavior on different types of models. But yeah, I think you can go to the related work and then the discussion to finalize.
Yeah, but the related work here is the part is like there are other researchers that have been in one of these papers here that he mentions is one that I already showed to you guys, and I will link it all this resource to the thread from the paper club. But one of the the important points here is that the explanation for such breakthrough phenomenon from another work that is related to this, other researchers also inferred that these multi-step tasks is that on these multi-step tasks, the probability of success of the tasks scales like the product of the success probability on each step, right? So if you have to predict the whole sequence of a word, the probability of having a final prediction that is that match exactly the final string will be a product of each correct prediction that the model performs, right? So this is very interesting thought that kind of help us understand the importance of having a prediction of having a performance metric that goes all the way from, if you have 10 tokens length string to match, that goes from the probability mass of 1 correct, 2 correct, 3 correct, 4 correct, and so on, and use this performance metric to evaluate the models instead of just the final one, the exact match string at the end of the prediction, right? So, and since we have mainly multi-step tasks being applied today, so the main power of those models are on this multi-step task, right? And we also have other papers that have stated, let me see, is this one here, like channel thought, how this can improve the performance of those models, right? And this is also being affected by the idea that we are using metrics that do not take into account the progression of the probability of correctly predicting each token and then having a new probability for the next token and so on until reach the full length of the prediction. But okay, so I believe we already talked about this alongside the paper, but the final statement here is that researchers are creating the idea of emergent ability by using metrics that will display this. So this is the final key point of the paper, and you cannot we cannot look at this paper as something that is trying to claim that there are no and there will be no emergent ability in the future for either large language model or other models. But for the claims that people are doing today about emergent abilities on models, they are being driven to those conclusions because of their choice of metrics. But this is specifically containing on today's claiming emergent abilities on models. So the author made clear that this is not something that he would claim for any other possible emergent ability on current and future AI models. Actually, the technical report for GPT-4, they extensively talk about how they want to correctly infer the future emergence of abilities and how they are concerned about investigating it further and being aware that some of it might be creations of researchers choice of metrics, right? And one of the researchers from OpenAI actually created a Rylan thread trying to also debunk the idea that the models display like abrupt and unpredictable performance emergent abilities, right? And he actually uses GPT-4 an example for on a task for inferring performance on programming synthesis. And by just changing the metric from pass rate to log pass rate, you you lose the sharp left turns, right? And also here, like the technical report from GPT-4 also displays this as other people have used the same performance tests to display an emergent ability, but on on the paper from OpenAI itself, from the GPT-4 itself, it displays the same test as not a sharp left turn, and it also uses and reinforces the conclusions for this paper that we just presented here. And there are actually other people also talking about like how the top one accuracy metric is kind of nonsense for some performance tests that should use a Breer score, which will use like the square mean of the model prediction and the target, right? Which would be a more precise and smooth a metric to use instead of top one accuracy. And there's here like reading this discussion here, like there are people
I think you can
fully
put on the document, because like
yeah,
this is,
yeah, well,
like, I don't feel like because we didn't read this, so I don't see.
oh no, yeah, I'm not going to read this one here. Just like showing visually that there is like forums heavily discussing these issues, not in an amateur manner, but in very
Yeah, but like I put
scientific
with
manner.
the paper club, we also have like is in the news, right? Of course, there's some news
Yes.
bias, which is I mean, that and nothing is the same thing.
Yeah.
You have like for Stanford research as well.
Yeah, and for our case, maybe I'm hallucinating a little about this, but actually no, this is not our internal data. But when you look to graphs, you like GNNs, you use some performance metrics that may fall into the same trap when evaluating the performance, right? Like the graphic explanatory accuracy here, for instance, that aims to measure the importance of a node or an edge or a subgraph on a prediction. If we take a look here on an example, like on an example here, like if you have, imagine you have the full Congress, right? And the full Congress, you have a bunch of politicians there, and then you have like a few politicians, you remove the label, the party label from them. So you don't know which party they have, but you still know the relationships on Congress. So shared votes with a given politician or another. And then you have the idea of predicting the final arrangement of Congress, right? You just remove the labels, you still know the labels, you maintain the relationship between the politicians, you remove the labels, and you want to predict what will be the final arrangement of the Congress later, right? And then if you use the metric for this graph explanation accuracy here, and you take into account that if you set up your test so the model will get will score 1 only if it predicts correctly the final arrangement, and you remove from the evaluation the progression of correctness per node. You know, if instead of per node error, you use like per graph error. Yes, exactly. And you will, as you maybe will fall in the same trap that we saw in the paper, right?
Yes.
You will display this model, this GNN model, as having an emergent ability because suddenly it can infer correctly the final arrangement of Congress. But actually, as you see in per node, you will see that as the model increases, it will get 1, 2, 3, 4, 5, 6, and then all the politicians correctly.
Yes.
But that's it, guys. Actually, I tried to get through a lot of here, but
yeah, but I don't know. I think you can go back to the paper, please.
yes.
Because I think this in the discussion is the I don't know. I think it's the main part, right? Because at least for me, the paper like I said before, like I thought they're talking more about large language models and stuff like that. But in the end, I think is the paper more about like the choice of a metric, and especially like the benchmarks that we have that we use, right? Because in the conclusion, I think one thing also that I highly recommend is highlighting the parts of the paper that you think are interesting.
Yeah, I tried to do this with the
Yeah,
highlight, but it doesn't work.
yeah, I use on the preview from Mac. But I think one of the things that I think are more interesting about the discussion is about like for this part, for instance, like no, not for instance, like it's on. Can you go a bit down?
What is the part?
Is the part that they discuss, like they were like learning about the big bench. While learning how to use the big
Yeah,
authors
this one
actually
here.
over that, like they give like the what's 4 plus 5, and then the model answers the sum of 4 plus 5, which is kind of similar to chain of thought prompting, right? And then it scores 0. Why score 0? Because on the benchmark they just put a reject and say, let's get the first number. The first number is the answer. So like it's also, I think, for large language models, especially these benchmarks, it also is not that simple to metrify what is correct or not, right? Because these like big bench, from Google and stuff like that, and like they evaluate the answer in such a, I don't know, it's very naive assumption that the model is just like 9 instead of trying to elicit any kind of reasoning. And then of course the paper does not go into prompting and anything like that. But it is also a thing, right? It's not only the metrics of choice that may impact, how we understand like this, and I say, oh, now it's going to be so much better. But also like the metrics itself, like how you measure if they're correct or not, is not that reliable, because like I think in the last not this paper club but previous paper club, they have like they compared some metrics like, oh, how many similar words you have compared to the answer. Yeah, I didn't paper club yet. And okay, like it's a lot of metrics that are really very hard to assess, I think, as well. So it's not only the choice of the metric, but also like how evaluate is correct or not as well.
Yes, and there's the point of the resolution, right? Having more test data, and following up the point of the rejects that they were not applying there, they're also not considering the for in a as a word, only as a digit. So if the model outputs it as a word, it will get 0 as well.
Yeah, so it's I don't know. I think like I said, the paper I thought at the beginning would be more about LLMs, and how we were not there yet about AGI stuff like that. In the end, I think like, oh no, it's more about the metrics of choice and stuff like that.
Yes,
and I think that's really interesting. That's a good point.
Yeah. Actually, this is also the reason why they test this on the deep neural networks for the image, for the vision tasks, right? To show that if you extrapolate this to other models, model families, you will have
not only LLM. Right? They say like, we do this for other problems, and I think of course they handpick the problems, like the image that they do about reconstruction, the figure 8 is like, it's so similar. I thought it was really, really funny. But yeah.
Okay.
Any comments, guys? Kind of got already on time.
Yeah.
Any other comments, guys?
So good. Thank you for the presentation. It was really clarifying.
Yes. Yeah, really nice. I think really interesting paper. I think because it makes you think, right? The choice of metrics and then stuff like that. It's very hard to assess stuff as well, because like I think maybe it's something that we don't think about too much, right? To say, oh, you have the accuracy F1 and stuff like that, which okay, for our case it's good enough. But for this other, how you solve the issue, it's like we have today with Claudio, right? How you metrify Claudio is like how many chats he closes, how many problems he solves, or like if he route this chat to another person, is that good or is this that bad? Because it's like it's not obvious when also this metric like really problem solving. But yeah, but also is a good point, right, Danielle and the other guys? Like we can also induce Claudio to have this this behavior, so we can show the guys, yeah, Claudio is increasing a lot since last year. Change the metric, so it's good for us to for sure our hands. But yeah, I think that's it, Danubio. So next
Okay.
one is Fabio, I guess. But yeah, have nice weekend, everyone.
Okay, bye-bye, guys. Thanks.